Hello everyone, this is Dr. Fan. In 1982, about 300,000 students took the SAT test, but nobody got question 17 right. And this is question 17. As you can see, this is a multiple choice question. It is almost impossible for 300,000 students all get this question wrong. So the only logical explanation is there is no correct choice. And this is exactly what happened. The test writer themselves got this question wrong. And this is a pretty big deal because the SAT score of all the students needs to be recalculated. But there are 3 students who are smart enough and they proved there was a faulty answer. Although this is an SAT question, but in reality, this question is about physics, and let's discuss it today. The question says, in the figure above, the radius of circle A is 1/3 of the radius of circle B. Starting from this current position, circle A rolls around circle B. At the end of how many revolutions of circle A will the center of circle A first reach its starting point? The question basically says, while A rolls one revolution around circle B, how many revolutions A should self-rotate? So in the mind of the SAT test writer, they think the radius of circle A is 1/3 of the radius of circle B, and the circumference of a circle equals to 2 pi r. So the total circumference for A would be 2 pi RA, and the circumference of circle B equals to 2 pi RB. And because RA is 1/3 of RB, so CA is 1/3 of CB. In other words, the circumference of A times 3 equals to the circumference of B. So they think if A rolls around B for one revolution, A should self-rotate 3 revolutions. So they think the correct answer is B. So that's the intended answer from the test writer. But in reality, all 5 choices are wrong because the test writer got confused about this physics situation. Let's evaluate from the point of view of physics. Alright, so this is circle A and this is circle B, and we know A rolls around circle B. These are several snapshots I have drawn. As you can see, while A orbits around circle B, A is also rotating. Why? Because if you pay attention to this red dot here, as A rolls around circle B, this little red dot is rotating at the same time. So rolling is a combined motion of orbiting and rotating. And let's compare what is pure rolling with pure rotating. On the left, we have pure rolling, and on the right, we have pure orbiting. Let's compare the difference. I have labeled 3 markers here. As you can see, for pure orbiting, all these 3 markers, they are having the same displacement. Their relative position would never change. This is pure orbiting because the circle itself is not rotating. But for pure rolling, while this outside circle is orbiting, it also self-rotates. So now we understand what is pure rolling. We can safely say that the velocity for pure rolling is a combination of v orbit plus v rotation. Okay? This is our circle A, this is our circle B, and this is the center of A, this is the center of B. And we know this is RA, and we know this is rb. Alright, then we know the orbiting velocity equals to the orbiting angular velocity times Ra plus Rb. So this angular velocity here basically says how fast A is orbiting around B angularly. But we know A is also self-rotate. The rotation velocity equals to the angular velocity of A itself times its own radius. So this omega A basically says how fast A is rotating angularly. And now here comes a very important thing about rolling. For rolling, the contact point of A and the contact point of B should not move relatively. And we know circle B is fixed, so all the points on circle B should be fixed, which is also true for this contact point with circle A. If there is pure rolling, that means there is no slipping. That means this point, this red dot on circle A, should have the same velocity as this point on circle B. And we know circle B is not moving, so the contact point on circle A should have a velocity of 0. We know for this contact point on circle A, its velocity coming from two parts, orbiting and rotating. And the contact point velocity equals to its orbiting velocity, which equals to omega b times Ra plus Rb, and which goes to the right. But its rotating velocity for this contact point is going to the left. So we need to minus omega A times Ra. Because this contact point velocity is 0, basically we know omega b times Ra plus Rb equals to omega A times Ra. And we know Ra is 1/3 of Rb. Then basically we know 4 times omega b equals to omega A. So what does it mean? That means circle A self-rotates 4 times faster than the orbiting angular velocity of A with respect to B. If A rolls around B for 1 revolution, A itself should self-rotate 4 revolutions. As a result, for question 17, the correct choice should be 4 revolutions, and all these 5 choices are wrong. It's pretty interesting to see a physics question show up on the SAT test, and it's even more interesting to see the test writer themselves got this question wrong. I hope you liked this video. Thank you. I will see you next time.